Hello, today we are going to continue our discussion of Chapter 10. Today we are going to discuss converting moles to grams and atoms and other representative units. So let's begin today's discussion with a definition of the term mole. Mole is abbreviated as MOL, and it is the SI base unit for amount. Now, mole is probably not something that you're very familiar with in your everyday life, so the best everyday life comparison that I can probably give to you is the term dozen. Everybody knows that a dozen means 12 of something. So you could have, a dozen eggs and a dozen elephants. What that means is you're going to have 12 eggs and 12 elephants. However, I think we can all agree that a dozen eggs, even though there's 12 of them, is going to have a much smaller mass than a dozen elephants, which would be 12 elephants. So while molar mass can change, like we talked about yesterday, a mole of lead would have a much larger mass than a mole of helium. The term mole in itself means 1 mole of anything contains 6.022 times 10 to the 23rd particles. 6.022 times 10 to the 23rd might seem like a very random number, but it's actually incredibly useful. That is known as Avogadro's number. It was calculated by a man named Amedeo Avogadro. So just like a dozen means 12, a mole means 6.022 times 10 to the 23rd particles. So let's talk about particles here, because particles can also be called representative units. So we need to kind of have a vocabulary lesson on this. The way that I compared it today in class is like when you are beginning to learn the English language and you're talking about singular and plural forms of words, like mouse. If you have a group of more than one mouse, you don't call it mouses, you call it mice, or goose becomes geese. We have some terms kind of like that in chemistry. And so one of those is if you have a mole of an element, a mole of elements contains 6.022 times 10 to the 23rd atoms. So it would be proper to say that 1 mole of nickel has 6.022 times 10 to the 23rd atoms of nickel in it. 1 mole of an ionic compound, though, has 6.022 times 10 to the 23rd formula units. The abbreviation for formula units is a small f period small u. Be careful with that one. 1 mole of sodium chloride, for example, since sodium chloride is ionic, contains 6.022 times 10 to the 23rd formula units of sodium chloride. You wouldn't say 1 mole of NaCl has 6.022 times 10 to the 23rd atoms of NaCl, because that's not correct. Those are not atoms. The smallest unit is a formula unit. Remember, ionic compounds are when you have a metal bonded to a non-metal, if you're trying to decide what type of a compound you're working with here. 1 mole of covalent compounds contains 6.022 times 10 to the 23rd molecules. Covalent compounds, remember, are all nonmetals in their composition. So an example of this is 1 mole of water contains 6.022 times 10 to the 23rd molecules of water, and the abbreviation for molecules is MOLEC. You wouldn't say that you have Avogadro's number of formula units of water, because water is not ionic, it's covalent. So you'll get better as you go along about deciding which words you should use, if you should use atoms, formula units, or molecules, but that's the basis for our definitions and our choosing of the words. Like I said just a little bit ago, the other thing that we can say about moles is you can determine how many grams are in a mole of a substance by calculating its molar mass, like we worked on yesterday. And the molar mass of each substance is unique. So like the molar mass of water is different from the molar mass of lead, which is different from the molar mass of hydrogen. So today we're going to work on conversion problems. We did conversions way back at the beginning of the semester. So just a review of conversion factors. When you use a conversion factor, you put the unit that you want to lose in the bottom of the factor and the unit you want to go to in the top, and you multiply by the top number, divide by the bottom number. So let's begin. Let me change my color here. And our first problem is find the mass in grams of 4.50 moles of calcium. So I'm going to start with the number 4.50 moles, and calcium is Ca. We are supposed to change that to grams of calcium. So I want to get rid of the unit moles. So I put moles in the bottom and I put grams in the top. Now here is a really, really useful tip. You always have 1 mole in these factors. It's always a 1 with the mole side of things. Now, to figure out how many grams are in a mole of calcium, you have to look at the periodic table, and you'll find the box for calcium and look at the number at the bottom of the box. When you do that, you should find that the molar mass of calcium is 40.08. So on our calculator, what we'll do is we will take 4.50 because that's our starting number, and we will multiply by 40.08 because that's in the numerator. Then you could divide by 1, but dividing by 1 is not going to change your number. And I get an answer of 180.36, and my unit label would be grams of calcium. All right, our next problem. How many moles of silver are in 5.27 times 10 to the 23rd atoms of silver? So this time, I'm starting with 5.27 times 10 to the 23rd atoms of silver. And I want to go to moles of silver. So do we have a link between moles and atoms, just like we had a link between grams and moles? Well, if we go back to our notes today, we do have the link that 1 mole equals 6.022 times 10 to the 23rd atoms. So I can do that in one step. I'm going to put atoms in the bottom of my factor because I want to lose that unit, and I'm going to put moles in the top. Remember, you always put a 1 with the moles, and Avogadro's number says that 1 mole contains 6.022 times 10 to the 23rd atoms. Now, when you go to plug this into your calculator, make sure that you use parentheses. So you got to put parentheses around this scientific number. You put 5.27, and then remember the shortcut we learned earlier in the semester to use the EE button, or times 10 to the 23rd. Then we need to divide by the parentheses 6.022 times 10 to the 23rd. If you don't use parentheses on your calculator, you're not going to get the correct answer. I have that when you plug that into your calculator, you should get 0.875. All right, next. What is the mass in grams of 7.5 times 10 to the 15th atoms of nickel? So this time we're starting with 7.5 times 10 to the 15th atoms of nickel. And I want to go to grams. Unfortunately, there's no direct link between atoms and grams. The only thing that we have is atoms to moles, and then we have molar mass for getting from grams to moles. So this is going to be a 2-step problem. So in my first factor, I want to get rid of atoms, and I'm going to go to moles. But I don't want an answer in moles because remember, we're supposed to give the mass in grams of this. So in my next factor, I'm going to put moles on the bottom, and I'm going to put grams of nickel on the top. Now, we always put a 1 on the side of the factor that has moles. To go from atoms to moles, we use Avogadro's number. Sorry, it's a little crowded there. And then to go from moles to grams, you have to consult the periodic table. The periodic table says that there's a mass of 58.69 grams in every mole of nickel. So now we need to plug this in. So we start with 7.5 times 10 to the 15th power. We're going to divide by Avogadro's number because it's in the denominator of the first fraction. Make sure you use parentheses. And then we are going to multiply by 58.69. And I get that you should have the answer 7.3 times 10 to the negative 7th grams of nickel Or if your calculator is not set in scientific, you'll get a decimal place with 6 zeros, 73 grams of nickel. I will be posting some additional sample problems that we worked through in class to help you with this, and make sure that you also work through the interactive tutorials and read the section in the book, then complete your 10.1 homework assignment online to complete